All right, chapter 4 review, linear systems and inequalities. A lot going on in this chapter, so let's jump right into it so we can get ready for this test. All right, number 1, graph the systems of equations below to find the solution. Of course, you could use substitution or elimination, but I want to see that you can graph these, find the intersection point. So let's graph this first one here in blue, 16x plus 3. So this is the y-intercept. So it crosses the y-axis at 3. Positive slope means I'm going up and to the right. So we're going up 1, right 6. Up 1, right 6. Then I would fly off the graph. I'm going to go down 1, left 6. Kind of stair step it out and connect those together. Then I'm going to do the next one in red. 2x minus 8. Y-intercept is down at negative 8. Slope of 2 means up 2 over 1. Remember, there's no bottom number, so you just put a 1 there. It's positive, so we're going up and right. 2 over 1, 2 over 1, 2 over 1. Boom, I just got lucky. I actually hit the spot right there. So I'm going to go ahead and finish this off, make it look pretty. But the answer to the question is that point right there. All right, that is the solution to this system. So x equals 6, y equals 4. Can also be represented as an ordered pair. So the answer there is 6, 4. And if you were to do substitution or elimination or any other algebra method, you'll get that answer. Graphing is pretty nice though when they're in slope-intercept form and they cross at a nice integer spot. All right, next problem, number 2. Ella made an initial deposit of $50. So let's kind of do Ella here in blue. So Ella, initial deposit of $50, and then she's saving $35 per week. All right. So a couple different ways I can attack this. We can look at Allie too. Allie made an initial deposit of $25, and she's doing $40 per week. So one way might be to make a table. So maybe I make this table, and I'm like, all right, let's just kind of, I got some room over here. I'll do Ella. And then we got Allie. And then we have kind of our time, so we'll start off at week 0, time 0. And we end up having, Ella starts with $50, and then she increases 35 per week. So I got to keep adding 35. So week 1, she's at 85. Add another 35. That'd be what, 120, 155. Another 35 is 190. Another 35, 2.25. Another 35, and hopefully that's far enough. Now we look at Allie. Allie started with less money. She only started with $25 initial deposit, starting amount. And then she starts putting in more money per week, 40 per week, so an extra $5. So at 40 per week, we are at 65, 105, 145, 185, 225, and then she passes her. We could go another one. So we find out, the ultimate question was, after how many weeks will they have the same amount of money? Well, they're going to have the same amount of money right here, which week 2, week 3, week 4. So it looks like the answer to this question is week 5. All right, so that's using a table. But if we kind of think of this table as a linear equation, basically what we did was we have a starting point for Ella. So Ella, she starts at 50. So that's kind of like my y-intercept. I start at 50. And then if we look at what she's going up every week, she's going up by $35. So that's the slope. That's the rate of change. So it's $35 times every week. And if you want to do Allie, we could do Allie. She starts at 25, but she has a steeper slope. She's going up 40. Should be a W. Looks kind of weird. And then I could use substitution, because they're like, hey, when does Ella equal Allie? When does E equal A? I could set those two equations to each other. Maybe I'll do that down here. and I'll get 35W plus 50 equals 40W plus 25. And then we just solve. So basically this was, when does Ella equal Allie? And I get my W's to one side, so if I subtract 35W from both sides, I'll have 5W. Then if I subtract 25 from both sides, I'll have that. And divide, and I find out the weeks equal 5. So you could do an algebra, you could use a table, you could graph it, lots of ways to do it. But that's what you do. All right, next question. Looks like we're number 3. Use your graphing calculator. So let me fire up the old graphing calculator here. Throw that little guy up there. Turn it on. And I got to get rid of these old equations I have in here. All right. I might want to check my window before I get started, but that doesn't really matter. It's probably not going to be right anyway. So I need to punch in y equals negative 1.2x. So y equals negative 1.2x plus 78.4. Lock it in. And then I have 2.8x minus 35.6. Lock it in. And now we want to graph these. All right, I'm trying to figure out where they cross. It says graph and solve the systems of equations, express using an ordered pair. So I go ahead and I graph these jokers. Hey, I got lucky. They actually crossed right there. Now, if I didn't, like let's just say that my window was, see how my x min, so my x's are going from negative 40 to 40. My y's are going negative 88 to 144. The axes look kind of weird because of my scale. Like maybe I wanted to go by 10. And maybe I wanted to go by 10. Let's see if that would look a little prettier. Yeah, now my grid looks a little bit better. But let's just pretend that your window was wrong. Let's go to Zoom Standard, which is number 6 there. Go down to number 6. And let's just say that we were in this window, because this is how your graphing calculator normally set up. Well, if you graph both lines, you don't see anything, because not much is happening in that view. We got to zoom out. So you could hit the zoom button, and you could either choose zoom out. Maybe I'll just do that. Maybe I'll just go down to number 3 and zoom out. And I hit enter. You got to hit enter after you zoom out. So I zoom out. Oh, not quite far enough. I could hit zoom out again. Zoom. Zoom out. Boom. You got to hit enter again after you do it. Now I'm like, oh man, there it is. That's a nice clean thing. And what we're going to do is we're going to use our trace function. So we're going to hit second trace, which is actually calculate. If you look in blue, it says calculate. I want to go down to number 5, which is intersect. And it's like, hey, do you want to do the first curve? And I'm going to move my toggle I'm like, okay, I'm on that line. Yes, this line. And then it jumps to the other one. It's like, do you want to do that line? I'm like, yeah, I want to do that line. Enter. And do you want me to guess? Sure. And now it's giving me the intersection. And I just have the answer. It's x is 28.5 and 44.2. Come over here, put my graph on here, or put my answer down. It is 28.5 and 44. Erase that, too small. 44.2. There we go. So sometimes when you're given this nasty equation, graphing by hand sucks, so you can use a graphing calculator. All right, moving right along. Let's get rid of that. Let's go to number 4, which is up top. If xy is a solution to the given system of equations, what is the value of x? So, and on some of these problems, I don't have enough room on here, so I'm probably going to rewrite them on a grid after this. So it'll be a little bit, I'll have more room. But this one I can probably fit on here. So let's see what we got. I think this one is set up nice for substitution. Notice that it's already set up y equals. We already know what y equals. So I'm going to just plug that in the top equation. So I'm going to go 3x minus 4, and instead of putting y in there, I put negative 1 in. And I just solve it. So this is 3x. Negative 4 times negative 1 is plus 1. Minus, or no, not plus 1. What the heck am I doing? So plus 4. Minus 4 to both sides. 3x equals negative 15. Divide both sides by 3. And I get x equals negative 5. And this one just says, hey, what's the value of x? So I know I'm done. I don't have to go any further. We don't need to go any further for this one because it already told me what y equaled. So there's no like subbing it back in like on other problems. So I go here to number 5. So let's check number 5 out. And I think I'm actually going to go off the grid for number 5. So let me grab a copy of the review so I can kind of look at this as we're going through. Some of these problems I just need more room. All right. So number 5 says we have 5x plus 2y equals 22. 4x plus y equals 17. And they want us to figure out what is the value of x plus y. And they're doing this because on the SAT, they know that you can sometimes cheat and just plug the answers in. So they're wanting you to find x and y and then add them together so that you can't kind of do that. So it's mainly for multiple choice situations. So when I look at this, I'm like, well, I could either A, solve it using substitution. Like some of you guys might choose to get the bottom equation equal to y. If you like to do substitution, you could do that. I'm going to choose elimination. Remember with elimination, I'm looking to get opposites. All right, that's my goal. I want to get opposites, like a negative 5 and a positive 5. I don't see them right offhand, but I do think if I multiply this bottom row by negative 2, I think I'll have negative 2y. So I'm going to copy down the top row. 5x plus 2y equals 22. And on the bottom, I'm going to get negative 8x minus 2y equals negative 34. And now once I get my opposites, I can combine the rows by addition. And I'll get negative 3x equals negative 12. Divide both sides by negative 3. Be careful. If you get a wrong answer for x, it's going to screw up your y as well. But I believe x equals 4. So now, in the grand scheme of things, I now kind of have part of my answer. It's 4 plus something. Now to get y, what I'm going to have to do is I'm going to have to take this 4, and I'm going to have to pick an equation to plug it in. So I'm going to take my 4, I'm going to plug it in right there. So when I do that, I get 4 times y plus y equals 17. So 16 plus y is 17. Minus 16 from both sides, you get y equals 1. So now I know that y equals 1. So my final answer to this question is 5. So that's the ultimate answer. Now, if it was just a straight up question and you wanted an ordered pair, the ordered pair would be 4, 1. All right? So sometimes they want x, sometimes they want y, sometimes they want the ordered pair. And now I'm even going to show you a shortcut. All right? So this is a nice little time saver. A lot of times on these questions, when they ask you to do something like that, there would have been a sneaky way in the very beginning to get the correct answer. So check this out. If you would have just thought to maybe try to subtract this problem, just as is, nothing matches, but just subtract it, you'll get x plus y equals 5. And you could warp speed right to the answer. So sometimes they do that. You know, they might have said, hey, what's 9x plus 3y equal. Well, you might have saw that, wait a minute, if I just add these two, equations, which you normally wouldn't want to do because you're not eliminating anything, but if you just add those two equations, you would get the answer to the question. Now, most kids are going to solve it for x, solve it for y, plug it back in. Most kids are going to take 2 minutes to solve this. But some kids who get a lot of practice, this is where I teach in integrated math next year, or this year if you're in it, is there are shortcuts that sometimes you can cheat the test. All right, back to the review. Let's move on down to number 6. So number 6, this one they want to know what is x minus y. Well, I don't know if I can shortcut this one yet, so I'm just going to solve it as is, but then we will come back and see if maybe there was a shortcut. So let's try number 6. We have 2x minus 3y negative 14. We have 3x minus 2y equals negative 6. So right away, trying to get opposites, I don't really see any, but I do think that if I multiply, let's say, the top row by a 3, maybe I'll do that row by negative 3, and the bottom row by 2, that way I will get, I'll get negative 6 and positive 6 in the x's. So I get negative 6x, positive 9y, positive 42. So again, remember, be sure to do this times all 3 pieces. Sometimes I forget the last piece and I screw it up. So sometimes I actually draw that on my paper just so I don't mess it up. And I get 6x minus 4y equals negative 12. I got my opposites. You know, that's what the goal was. It was right here. It was trying to get those opposites so that now I can add this thing together and they go away, they eliminate. So my x's are gone. I now have 5y equals 30. Yeah, that's right. And then y equals 6. All right. So I got y equals 6. I think we were trying to solve for x minus y. So I got that part. Now I got to go back and get x. So I'm going to substitute that y in. Maybe I'll just pick the bottom equation. 3x minus 2 times y, which we now know. And let's get after it. 3x, take away 12, negative 6. Add 12 to both sides. Divide, divide. I get x equals 2. So 2 take away 6. Final answer would be negative 4. If you just wanted the ordered pair, it would be 2, 6. All right, number 7. And actually, I want to go back right now and just see if there was a way to cheat this problem in the very beginning. So I'm just kind of see if this was cheatable. Sometimes it is, sometimes it isn't. Is this one cheatable? Well, adding together, I would get 5. Let's just see. If I add these, I would get 5x minus 5y equals negative 20. Oh, and then if I just divide everybody by 5, I would get x minus y equals negative 4. What do you know? There was another way to cheat this. So keep an eye out for that on the test. You know, you guys that watch the video, you get a little extra something, something. Kind of helps you out when the test comes. Number 7. What do we got going here? So this one has fractions. So remember, to clear out fractions, you can just multiply everybody by the bottom number. If they're harder problems, sometimes you have to multiply by the least common multiple. If there's like something, you know, like you might, this is not having anything to do with this problem, but You might have like a 1/2 x plus a 2/3 y. Well, you can't multiply by 2 or 3. This would be a situation where you're going to have to multiply everybody by 6. But this problem's a little easier. So I'm going to just multiply this first equation. I'm going to multiply both sides by 2. And I get y equals 8. Now on the bottom, if I multiply everybody by 2, I'm going to get 2x minus 1y equals 4. So now I have a new system that looks way easier. And I'm just going to use substitution here. I'm going to take that 8 and drop it right in there. 2x minus 8 equals 4. Add 8. I get 12, divide. I get x equals 6. And that's what they want. Correct answer, D. All right, that one was straight off of the SAT. Keep on going. Number 8, graph the system of inequalities and shade the solution region. All right, so first thing I need to do is I don't want to graph it the way it is right now. It's in standard form. I want to graph it in slope-intercept form. So I'm going to solve for y. So we'll make the top equation the blue equation. So I'm going to move the 2x. I'm going to subtract 2x from both sides. And I get negative y less than or equal to. I'll have the minus 2x there, the positive 1 here, and divide both sides by negative 1, because I need positive y. Well, when I do that, I get my positive y, which is sweet. Here's where you got to be very careful, though. You got to flip that sign, because you just divided by a negative. So don't screw that up or your shade gets all goofy. I get 2x minus 1. So now let's graph this. So just like normal slope-intercept form, I have a y-intercept at negative 1. I have a slope of 2, so put a 1 under it. Up 2, right 1. Up 2, right 1, 2, right 1, 2, right 1, boom, boom, boom. And since it had an equal to bar on it, it's going to be a solid line. It's not going to be dotted. And now I got to pick a shade. 2 ways to shade. One way to shade is choose a test point. If possible, always choose 0, 0, as long as it doesn't live on the line. And if 0, 0 works in the equation, you shade that side. If 0, 0 doesn't work, you shade the other side. So like on this one, if I did 0, 0, I would get 2 times 0 minus 0. And then I ask myself, is that true? Is 0 less than or equal to 1? Well, yes, that is true. So I would shade that side. Now, it would have been easier to peek and see that if this is greater than, you always shade above the line. So right now, all of these xy's are solutions. They all prove that inequality true. So I'm halfway home. Now we got to do the other one. Solving the other ones for y is a little easier because it's positive. So I'm going to have y when I move this 2x to the other side. Subtract 2x from both sides. I get that. Crosses at a positive 3. Go up to 3. Slope of negative 2. So I'm going down 2, right 1. So down 2, right 1, 2, right 1, 2, right 1, 2, right 1. I got to be careful on this one because since this doesn't have the equal to, I want to make sure this is a dashed line or a dotted line. So I'm going to dotted line it. Dash, I say. Gone. Now I got a shade. I'm going to use the little trick on the shade. The trick, remember, on the shade is since this is less than, I'm going to shade below the line. So I'm shading, I'm shading, I'm shading, I'm shading. And then all of a sudden, I start double shading. This is the region that gets double shaded. So my final answer to the question, like to get full points, are where is the double shade occurring? And it's occurring all in this area right here. So that should be shaded darker, if you have colored pencils or something. That's the shaded area. Whenever it's two lines, it's just going to be one of the x's like that, one of the pieces of the x. All right, moving right along. Number 9. Oh, we got some directions here. Use the information below to answer 9 through 12. And they start talking about bookstores. So this is one of those linear programming problems. If you're struggling here, go back and watch the 4.4. Oh, still got fat marker on. Be gone, fat marker. We want medium marker. So go back to your 4.4 notes to check out some examples of this. And I kind of broke it up into 4 problems instead of one giant problem. So here we go. And I'm going to scroll up just a little bit so I can see get a little bit more white space. All right. So hardest part is let's go through and sift out what's important out of this problem. So a bookstore manager is purchasing new bookcases. So those are the things that we're talking about. The store needs 320 feet of shelf space. All right. Bookcase X. All right. So here's where we start getting into something. Bookcase X, and I'll do this in blue, provides 32 feet of shelf space and costs $200. So I got 2 clues about X. Bookcase Y, 16 feet of shelf space, costs $125. Because of space restrictions, the store has room for at most, so this is X, at most 8 of X, and at most 12 of Y. All right? Now notice they did talk about money, but they did not talk about a constraint with money. They didn't tell me how much I had to spend. So the money issues are not going to show up in the constraints because I don't have a limit. They didn't say, hey, you only have $1,000. So I think that's going to be my objective equation coming up. So I'm kind of just thinking about the money coming up later. All right, well, let's see what we can put together with constraints with some inequalities. And one fact that we needed was the store they need 320 feet of shelf space. All right, so let's think about our X and Y. Let's start right off with that. When I add in all the shelf space, so it says X plus, well, let me see here, 32 feet. So first of all, I'm going to start kind of easy. I'm going to go to the bottom here. At most, we can only have 8 X's. All right? So X has got to be less than or equal to 8. And Y has to be less than or equal to 12. Because, you know, if I define my variables, X equals the number of bookcase X, you know, and Y equals the number of bookcase Y. So I got to have less than 8 bookcases, less than 12 bookcases. Well, let's get into the space here. It says that every X bookcase is 32 feet. So I have 32 feet times every X bookcase of shelf space. Probably not one shelf 32 feet long, but it's probably stacked up high. Plus, I have 16 feet for every Y bookcase. And I need that to come out to be 320. Now, it didn't say less than or greater than or at most, so I'm just going to put equal to 320. And I guess I could probably interpret this as less than or equal to 320. I'm going to kind of interpret it that way. And it won't really matter as much. You'll kind of get the idea of where the shade's got to happen. And right now, let's just leave the money because I don't really know. Like I look over right to the right where it says write the objective function. I think right now we could do this because it says write the objective function and use the vertices, which we don't know about those yet, but to find the minimum cost for the project. So our goal is to minimize cost. So that tells me that the money is not going to be in the constraints. It's going to be in the objective. So the cost for the project is, well, it's going to be $200 times every X bookcase. And the Y ones are smaller, so they're cheaper. They're $125 for every Y. So eventually, this is going to be the equation where I plug in my vertice points to see how to minimize costs. Like, I don't want to spend a bunch of money. All right? So I think we got 9 and 12 partly knocked out now. Let's go and do some graphing. So I need to kind of keep what we had in mind there. X less than 8, Y is less than 12. So let me scroll up to right here. And I think if I pull my grid up, it'll still show up over there. It does. So I'm going to get rid of you. And I'm going to leave those up over there so we can graph these nice. So let's go in and let's start graphing them. Well, the blue line is X has got to be less than or equal to 8. So remember, X's are the vertical lines. Cross the X-axis at 8. So we're talking about shading all of this. You know, you could take forever to shade that, but just shade that however you want, going that way. Well, Y has got to be less than or equal to 12. So Y's are horizontal. So Y is less than or equal to 12 means I'm shading down. And really, if you want to, you can just kind of shade the overlap. Like, there's no sense in shading all the way to the right. I mean, technically, yes, this stuff is shaded, but why clutter up your mind? Let's just focus on the part we need. And now we need one other piece. We have to shade this, this equation here, which I'll do this one in black. And I'm going to use intercepts because I notice it's in slope-intercept or standard form. And I picked a nice one so that we can use intercepts. So remember, with intercepts, you're just finding out what is Y when X is 0 and what is X when Y is 0. Do this a lot, so you need to get good at finding intercepts, also on the SAT. So when X is 0, you can't see me right now, but I'm covering up the 32X and just looking at the 16Y, and that comes out to be 20. And then I kind of put 0 in for Y, so it's going to wipe out the plus 16Y chunk, and that's going to be 10. And this is going to help me graph. So now I have intercepts at 0, 20, which is way up here, and then 10, 0, which is way down there. And I could put up a ruler and kind of cross these, but I kind of see the slope has got to go down 2 over 1. Like, I just kind of, and I could use my trick from back in chapter 2. Remember, our trick for slope was opposite of A over B, which would be negative 32 over 16. So I could also use that to cheat and know my slope is negative 2. So I'm going to do this just so that we get some good crossing points, because if you're crappy on how you graph, the crossing points aren't going to be crisp and they're not going to show up where they're supposed to. So I'm coming down. There we go. And I now can see, and if I graph, you know, if I shade, I got to shade less than. And actually, if I need 320, thinking about this, if I need 320, I can't be less than or equal to 320. I don't know what was I thinking earlier. You guys let me screw that up, man. Not that you could yell at me through YouTube, but maybe some of you were. So I got to be greater than, because I need 320. I can't have 0 or something. So when I start shading that way, and I'm going this way, the interesting part, the overlap of all three is right here. That's the overlap of all three. So let's go in here and let's kind of see what we have for our region. And I got that, I got that, and I got that. So let's kind of see what we have going on here. So my vertices are, and this is going to kind of be important down on the next screen, but my vertices are 4, 12, looks like 8, 12, and 8, 4. Now, I wrote them as ordered pairs. You could also, think of these as a table. Remember, X was bookcase X, this was bookcase Y. So those are my vertices. So when I come down here to answer the next question, I'm going to make these come back. What are the vertices you need? Booyah, there they are. So let's kind of come over here and let's get rid of all this other stuff. All right, and now I think I'm ready to test out the objective function. So remember, the objective function, we had already written this down, was the cost was 200 times every X plus $125 for every Y, and we want to get the minimum cost that we can out of this. So when I do these, if I do 4, 12, well, 200 times 4, that would be $800 plus 12 times 125. Let me bust out a calculator here. Should be able to do that in my head, actually. 1250 plus 250, that's what, 1,500? See if I can do it without a calculator. Hopefully I don't screw this up. So that's $2,300. Well, 812 is automatically going to be more. So I don't need to really do 812. I could if I wanted to. That'd be $1,600 plus $1,500, which would be $3,100. But who wants to maximize, cost? That's not smart. And then I have 8, 4. So let's try 8, 4. Well, 8 times 200, that would be 1,600. Plus 4 times 125 would be 500. Ooh. Looks like that's a cheaper way. So it looks like the final thing to find the minimum cost, the minimum cost is going to be $2,100. So $2,100 minimum cost, and we would need to order 8 of the X and 4 of the Y cabinets. All right, that's a pretty involved problem, man. That's 4-4 linear programming. All right, now we get into the cool stuff that I like, the 3D stuff. So we're now entering into 4.5 territory. All right, 4, 5. And I put this new type of grid on here called isometric graph paper, which is really good for 3D stuff. You might have seen this in CAD. The graph's going to look a little bit different than this one to the right. So I'm going to kind of show you how you're going to want to kind of set this one up. But your z-axis is pretty straightforward. And remember, this is z that's negative. This is the positive z. Well, now is where instead of the y going straight out, we need to kind of either pick a direction, either going up or down. So I'm going to have the y kind of run like this. I could have had it going up the other way. It really doesn't matter. This thing could be rotated. So this is the positive y. This is the negative y. And then crossing right there in the center is going to be my x, and that's negative, and this is x positive. Big thing to remember is when you travel from x to y, you have to be going counterclockwise, going positive to positive. So if you notice right here, if I start at x positive and you travel counterclockwise, you have to then hit y positive. If you don't, you have it set up wrong. So if I kind of just spun this, you actually could have your x positive here and your y positive there, and you'd still be in good shape. Some people might choose to do it that way. Totally up to you how you do it, but I'm going to stick with how I did in the notes because that's how I saw a lot of other YouTubers and other professors and college websites setting theirs up that way. All right, so here we go. This is going to make it a lot easier. So when I want to graph this point 3, negative 2, 4, what I need to do is I need to go 3 in the x direction. So I start at 0, 0, the origin. 3 in the x is going to go 1, 2, 3. I stop right there. Now, and I kind of miss my line a little bit. That bothers me. I think I need to tighten that up. Just, if you're going to do it right, man. With a fat marker, preferably. There. That looks a little better. So now, I'm going to go 3 in the x, positive x direction. Right there. With arrows. Then I got to go 2 in the y. Well, 2 in the y is this way. And this is kind of nice because it gives you the streets to walk on that make sure that they're parallel to the main axes. That's what's hard about the other pictures. And then from there, I need to go 4 up in the z direction. So 1, 2, 3, 4. And right there is the final answer. Like this is the location. That's the answer to the question. That's the point flying around in coordinate space that's 4 above the floor. Now, if I were to do this over here on the one on the right, I'm not doing this problem, so just ignore this for the moment. But if I was doing this over here to the right, basically it's harder because what I would have to do is I would have to say, all right, I'm going to come 3 in the x direction. And now when I went 2 in the negative y, I got to kind of try to make sure that I'm parallel to this line and equal distance to that line, which is kind of hard because it's going to put me like somewhere over in here, somewhere over in that area. All right. And then I need to go up 5, or actually 4. So however long that line is, I need to go that exact same length, and I need to translate it straight up, which is going to put me somewhere. And here's where you got to kind of have to guess a little bit. You can almost be like, well, if I'm right here, I got to go 1, 2, 3, 4, 5, or 4. I keep saying 5. Start here, go 1, 2, 3, 4. It's going to put me somewhere in this area. So if I were graphing it on this graph, there's my spot. Now you might notice and be like, well, wait a minute, that's weird. Why are you so much higher than the y-axis? And it's just because of how this grid is rotated. It kind of goes back to, if you look at GeoGebra 3D, it kind of goes back to how that graph is rotated. And we can talk about it in class if you have more questions. Or you can go back and watch the GeoGebra 3D video in the notes. All right, moving right along, number 4. So I just want to give you more practice. We don't have the isometric graph to help us, so we're just going to kind of graph this thing old school. So here we go. I got to do x, y, z. So 2 in the x direction. 1 in the y direction. That means I got to go that way the exact same amount in parallel down here. So somewhere over about like that. And then I need to go 3 down. So somewhere in here, somewhere right there, is going to be where I'm at. Now, this is what's hard, is it kind of looks like we're on that line, but we're really not on the line. We're kind of like behind it. You know, so if I did this same graph up above on the other one, just because of how it's tilted, it might be easier to see. So let's kind of go up above. Let's kind of look at what this would look like up here. If I kind of do that, I think we had x coming this way. We had y going that way. Y, x, z. Well, if I do it on this one, -2, 1, -3, I would go -2, then move 1 block in the y direction, and then 3 blocks down. Now you would see that our point isn't really on that line. But because the grid is like tilted, it's almost like rotated down more. It's almost like you grabbed the top arrow of Z and pulled it towards you. So you're looking for more in above view. But now you can kind of see that it's not really on that line. So it all depends on your perspective of where you're looking from. One more. I'll just do this one really quick because you're probably ready to do the tougher ones. So on this one, 0, 2, 3, 0 means we don't move on the z-axis at all. And if I go 2 to the right, and then 3 up, the ones with zeros are easiest because there's no diagonal lines. You're just right there. So the final answer to the question is right at that spot. All right? You're right in line with the z-axis, just straight up above. All right, number 15. So this one we don't have the isometric paper, so we just got to try to bust it out. So graph the point 0, 2, 3. So 0 means I don't move on the x and y. 2 means I go 2 to the right on the y-axis. And then I have to go 3 up. So 3 up is, and I can just go straight up here. And there we are. We're at our point 0, 2, 3. All right, moving right along. Number 16, sketch the plane. So on these ones, you basically are going to graph using the intercepts. So I want to find the x, y, and z intercepts. So those are usually pretty easy because all you have to do is plug in 0 for the other numbers. So for the x-intercept, I'm going to put 0 in for y and z. So I kind of cover up this part. Oh, excuse me. I'm trying to find x. So I'm going to put zeros in for y and z. So 4 times 3 is 12. So there's that one. Now if I want to find the y-intercept, where you cross the y-axis, I put 0 in for the other two. So I put a 0 in for x, a 0 in for z, and 3 times 4 equals 12. Love graphing with intercepts if possible. It's really easy. It's fast. You can do this with standard form as well if the numbers are friendly and play nice. For my z-intercept, cross out these two. And there we go. So those are my points I have to graph. Those are the intersect spots. So let's graph those. 3, 0, 0 says go 3 in the x direction. Stop. And then y direction, 0, 4, 0. So I got to go 4 out here. All right. And then I got to go 2 up. So right there. And now, a lot of times, I mean, this is technically it's not a triangle, but I'm going to graph the plane using a triangle to show that it's in the front. It's in this front quadrant. And it's leaning backwards, and it cuts right through at a height of 2. So imagine not a triangle, but imagine like a full sheet of glass cutting through those 3 spots. And you can go on GeoGebra 3D. I'm not going to do it again because I've done it several times. But you can go on GeoGebra 3D and see how to do it. If you want to see that, go back and look at my 4.6 video notes, and it'll show that. Now, if you were, so this is kind of another way of doing this. Let's just say that you're doing another problem. Well, maybe I'll do the next problem. Maybe it happens on this one. If it does, cool. If not, I'll show you at this point in time. But everything starts off the same. So I'm going to do x, y, z. I'm going to go a little bit faster through this one. So I got to fill in zeros here, zeros here, zeros there. And the first one is going to be, that's -2. Just solving the y portion, that's going to be -3. Solving the z portion, that's going to be 4. All right, so let's see what happens on this one. So x of -2 means I'm going to go back 2. So it's going to cross through that back corner. Yeah, this one's going to work out nice. So y of -3, I'm going to cross over here. And then z of 4 means I'm going to cross up here. So when I connect these guys, I really want to be careful how I shade, because this is not going to be in this front quadrant. It's actually in the back there. So how I can show that is I can make sure I draw this line and it stays strong out in the front. And then what I can do is I can shade in the background. I can shade in the background, you know, this little plane back here. But I keep that black line in the front. So that kind of shows some depth, and it shows that my plane is actually coming from the back region and angling towards the front region. So that's just kind of a nice little effect of putting that in there to show, you know, that it's actually back there. Because if I just shaded it solid red, it's a little bit not clean on where it's at. So you can kind of show depth with that. All right, number 18. Basically on this problem, we have a 3 by 3. We have 3 equations. Whoop, get my writer going here. We have 3 equations, 3 unknowns. And this can't be solved until I can whittle it down to 2 equations, 2 unknowns, which if you go back, I believe this was in section 4.3 is where we were doing elimination and substitution. Maybe it was 4.2, kind of forget back that far. But one of those 2 sections. And what I need to do is I need to kind of look at this grid and see, is there a way I can combine 2 rows to eliminate a letter? And I try to look for the kind of the easiest mark. So when I'm looking through the X's, I notice right away I have a set of opposites. If I add rows 2 and 3 together, I can get rid of X. There's really nowhere else where I can do it without having to multiply a row. Like I kind of see that I'm close here. I would have to multiply a row first by a negative and then add them, which is just more work. So I think I'm going to choose to eliminate X. So that's my plan. I got to stick with it now, moving forward. Eliminate X. And what I'm going to do is I'm going to add row 1, or check that. I'm going to add row 2 plus row 3. All right, so row 2 plus row 3, and that's going to be my move. So we do that, and I'm like, all right, I add them up, the x's disappear. I get 2y's plus 4z's equal 24. And now I need to use 2 different rows, either 1 and 3 or 1 and 2, to get rid of x again. All right, so I want to get rid of x again. I don't know. The easiest way maybe I'm going to multiply this row by 5, and then I'll add 1 and 2 together. All right, so if I kind of write down what I'm doing here, I'm going to add row 1 plus 5 times row 2. So let's kind of work that out, see what happens. And I'm going to kind of go here, over here off to the side. So row 1, that's where I'm kind of doing my scratch work. That's row 1, and I'm going to add row 2 multiplied by 5. So that's going to wipe out x's for me. 25y. Ooh, this is kind of weird. Just wiped out z's as well, which that was a very unexpected bonus. That's amazing when that happens. So let's kind of look at this. So right now, when I combine these two, x's go away. I get 21y's. Z's go away, which really don't happen a whole lot. And I get 42. So I got so lucky. You know, I come over here, I really got 21y equals 42. Normally, you would have a z in here, and you'd have to solve that smaller system. But man, somehow we got really lucky. We're just going to be able to get our y answer right away. So we divide both sides by 21. This is lovely when this happens. I now have y equals 2. So what I could do at this point is I could plug that 2 in right there and figure out what z is. So we do that, and I get 2 times 2 is 4, plus 4z It's 24. Subtract 4 from both sides. Divide both sides by z. And I'm like, awesome. I got z equals 5. So now I got to do a little double plug action. I got to plug the y in. So maybe, and I got to come up here to do this. So I'm going to plug the y equals 2 in there. I now have a z that can get plugged in. And you can pick any equation you want. And now I need to solve that equation. So you're always going to do this little double substitute move eventually to get your answer. So I do that row. I don't have x. I do have y. I do have z now. It's 5. And that comes out to be 18. So x minus 6 plus 25 is 18. That's x plus, what's that, 19 equals 18. Minus minus negative 1. So I got the final answer. That magic point in space where all three planes happen to intersect each other. Negative 1, positive 2, positive 5. Now I did graph this. Hopefully we will see this intersection point on the graph. So I'm going to come over here and I'm going to go to GeoGebra 3D. And I punch these equations in. I put them all in. And right now when I look at my graph, somehow it's not loading for me. Oh, there she goes. So now when I rotate this thing around, you got to kind of play with it to get the right spot. But it looks to me like they're crossing somewhere right up in here. Somewhere right up in there. What looks good for a z of 5. It's kind of hard to see where the x and y, I might even have to kind of come up above to kind of get a little perspective of where it's going. Kind of hard to see there. It looks like my y is at 1, and it looks like my x is somewhere in the neighborhood of 2. It's kind of hard. You kind of got to keep rotating at different views to try to really figure out where this point is. But I think that it kind of makes sense, especially my height seemed like it was looking pretty good. So just a little something to check, see if we're doing it right. Kind of hard to see though, to be honest. But it's cool. I like to do it. All right, last one. This video is getting long. My voice is getting shaky. Let's try to rack out this last one. So I need to eliminate somebody, and nothing looks easy. I'm looking through here, crap, nothing's nice. Looking through here, crap, nothing's nice. Looking through here, nothing's nice. So I'm going to have to multiply a row. So the first thing that jumps out at me, and you can go lots of different ways, I think if I multiply this row by 2, I could then add these top 2 rows together, and I'm going to eliminate x. So that's going to kind of be my choice. So here we go. Top row, leave alone. Bottom row, multiply by 2. That way I know it's going to be a harder problem because I didn't just get a gimme right off the bat. But hey, this is honors. That's what we're built for. Tough problems. So I come in here, I add them together. X's go away. So I have decided we are going to eliminate x, and that's our plan. We have to stick to it from here on out. So I have 14 y's plus 10 z's equal 18. So what I've done is I've turned a 3 by 3 into a 2 by 2. Now I got to do it again, but I have to stick with this plan. I've just done it once. I now have to do it twice, but I got to pick 2 different people. So I can't use rows 1 and 2 anymore. So when I went up here, this was row 1 and this was row 2. So maybe I'll use 2 and 3 to eliminate x, which wouldn't be too bad. If I want to eliminate x with row 2 and 3, I am going to have to multiply a row by a negative 1. So let's kind of do that work. Multiply the row by negative 1. Then I got to add that to the bottom row. Oh man, I'm about to get lucky again. Holy smokes. This is pretty sweet because, man, I've gotten lucky on both of these problems. This is kind of weird. So those two go away, and I get negative 6y. These disappeared. And then I get, what's that, 18? Wow, divide. Y is negative 3. Normally you don't get that answer that fast. Again, typically I would get another equation there that I'm going to have to then use elimination to figure out. But I got really lucky here. I got y equals negative 3. So, hey, don't hate it. Just roll with it. So we're going to put this negative 3 in. I'm going to get 14 times negative 3 plus 10z equals 18. So that's negative 42 plus 10z is 18. Add 42 to both sides. I get 10z equals, is that 60? So z equals 6. And now that z equals 6, I should be able to go back to one of my original problems. So I get to choose, from any of these, where to plug my y and my z in. That middle row looks really nice because it's all positive and there's no number in front of x. So I'm going to choose that row. X plus 4 times y plus 3 times z equals 9. So that's x minus 12 plus 18 equals 9. That's x plus 6 equals 9. Awesome. So final answer, written as an ordered triple. 3, negative 3, 6. All right, I'm going to do a couple more questions in class tomorrow and try to find somewhere we don't get lucky and we got to work a little bit harder. So I'll have a few of those for you tomorrow. See you.